Good morning, my dear students. I hope everybody is fine. Let's continue the oblique projectile motion. So the concept we were learning was oblique projectile of motion. Oblique projectile motion is what we have discussed so far, the same thing. So there is an x-axis and y-axis. So this is the projectile. All right, part of the projectile is parabola. All the things we had already discussed. This is what oblique projectile means. At an angle with horizontal, we have projected. In this, few more numericals. Few more numericals let us discuss. Right? After few more numericals, we will be learning a concept called horizontal projectile. What is this? Horizontal projectile. Here also we will be proving that the path of a projectile is parabola once again. Let's discuss the first numerical for today's class. See how important numerical it is. And in most of the years, this numerical is the question asked in the previous NEET exam, JEE exam, and CET exam. It's a commonly asked question in the NEET exam. Let's discuss. The given diagram is like this. Okay. So, dear students, given diagram is like this. Okay, here. Right. See here, this is x-axis and this is y-axis. It's a given diagram and one. This is y and this is x. Okay, this is x. So that means the particle is at this point, coordinates x comma y. So this is x-axis. It is not x point, it is x-axis. So this is y-axis. All right. Now, look at the interesting part here. This is the projectile motion. So the angle of projection also I need to mention. So this is the angle of projection, theta. Okay. And there's a triangle here you can see. So this is the base of the triangle. And the base of the triangle is the range of the projectile. Yes or no? This is the question. Given diagram only I am explaining. Diagram they are not asking you to draw. This is the range of the projectile. It is x and the remaining distance is r minus x, my dear students. Remaining distance is what? R minus x. So this is the base angle here alpha, and there is another base angle which is beta. Okay. Now, what is the question? The question is to prove, carefully, question is to prove tan alpha plus tan beta is equal to tan theta. Tan alpha plus tan beta is equal to tan theta. Alpha is what? One base angle. Beta is what? Another base angle. And if you carefully see, the theta is angle of projection. Okay. So let me write here. Theta is angle of projection. Okay. It's not the difficult thing. It is an easy concept. If you know this alpha value and beta value, you can find this tan theta value. How simple it is, I'll tell you now. Listen carefully. Look at the solution, my dear students here. Here, what is tan alpha? Let me write tan alpha. What exactly the tan alpha is? Tan alpha, can I write it as y by x? In the same way, what is tan beta? So tan angle is what? Opposite side by adjacent side. Tan beta is y by r minus x. So let me write tan alpha plus tan beta value here. What is that? It's y by x plus y by r minus x. So I can take common. So tan alpha plus tan beta. If I take common y, so your value remained will be 1 by x plus 1 by r minus x. So this I can also write, y is already taken common. So x into r minus x is the LCM, and the numerator we get it as r minus x plus x. Carefully see. So this minus x plus x cancel, and you get y into r by r minus x into x. Carefully see. This is the equation 1. What is this? So this is tan alpha plus tan beta. Okay, then we need to find tan theta. If your tan theta value is also equals to this value, so then your relationship is correct. Otherwise, it's wrong. And finding tan theta, how you will find it? We have the concept called path of a projectile is parabola. So no, path of a projectile is parabola. From projectile equations, y is equal to ax minus bx square. So from here you can find tan theta into x minus g by 2u square cos square theta into x square. Here, in the last class, we had clearly discussed x tan theta. If you take common, we get 1 minus x by range of a projectile. Okay, so let me write once again. So y is equal to x tan theta into 1 minus x by r. We have proved it. And from this equation, what I can write? X into tan theta into r minus x by r. Can I write like that? R minus x by r. So from here, I can write y into r is equal to r minus x into x tan theta. So from here, what I can write? Tan theta value is equal to, carefully see, y into r by x into r minus x. Okay, so this is my tan theta, and you have equation number 2 now. Equation 2 and equation 1, both are same or not? Both are same or not? That's my question. Equation 1 and equation 2, both are same or not? So 100% equation 1 is equal to equation 2, right? So y into r by r minus x into x. Here also y into r by r minus x into x. So I can finally conclude that, what is that? Tan alpha plus tan beta is equal to tan theta. Remember this equation. This helps you a lot. this way, commonly the numericals will be asked. See, one more question, let us see. Let's check one more question, my dear students here. The question here is the velocity of a projectile. Look at the question. The velocity of a projectile when it is at the greatest height, when it is at the greatest height is root 2 by 5 of its velocity when at half of its greatest height. Find the angle of projection. Find what? Find the angle of projection, my dear students. Read the question once again. Read the question once again. The velocity of a projectile when it is at greatest height. So projectile at the greatest height, we know the concept here. So this is the projectile at the greatest height. So at the maximum height, the velocity is only u cos theta. Will you agree with this? This u cos theta is root 2 by 5 times of its velocity at half of the greatest height. You get here? At half of the greatest height, what is the velocity, my dear students? So at half of the greatest height, let me write here, at half of the greatest height, so velocity is equal to u into square root. So 1 plus cos square theta by 2. In the last class we discussed about this. Now, at a maximum height, so the velocity is just u cos theta. Okay. Now, at the maximum height, so velocity u cos theta is equal to root 2 by 5 times of this value, velocity at half of the maximum height. So that is u into square root 1 plus cos square theta by 2. Then find the angle of projection. You need to find the angle of projection. Are you ready? So simple. So simple. Just square root of both the sides here. So this will be u square cos square theta, which is equal to u square into 2 by 5 into 1 plus cos square theta by 2. So simple. So u square cancel here, 2 also cancel here. So 5 cos square theta is equal to 1 plus cos square theta. 5 cos square theta and this cos square theta comes here, that will be minus cos square theta. So 5 minus cos square theta, let me write here. 5 minus cos square theta will be 4 cos square theta, which is equal to 1. So then cos square theta will be equal to 1 by 4. Here, if you apply square root on both the sides and you get cos theta value will be root 1 by 4. So that is exactly equal to 1 by 2. And theta value is how much? When cos theta is 1 by 2, so definitely theta must be 60 degrees. So that is the answer. Alright. In this way, numericals will be asked here. One and only important thing you should remember is this, right? So, velocity of a projectile at half of the maximum height, which is equal to u into square root 1 plus cos square theta divided by 2. Clear? Great. Let's see one more numerical for your better understanding. Look at this. Here, question is a ball is thrown. A ball is thrown from the top of a tower. A ball is thrown from the top of a tower of 61 meters height. So height of the tower is 61 meters with a velocity of 24.4 meters per second at an elevation of 30 degrees above the horizon. See, 30 degrees above the horizon. This is angle of projection. Okay. Now, what is the distance? The question is, what is the distance? Distance from the foot of the tower, from the foot of the tower to the point, carefully see, to the point where the ball hits the ground. Where the ball hits the ground. All right. Read the question once again here. A ball is thrown from the top of a tower of 61 meter height. So let me draw a rough diagram for you to better understand here. So there is a tower of height 61 meter. A ball is thrown from here with a velocity 24.4 meter per second and an elevation 30 degrees. Look at here. So this is how it is happened like this. This is what the projectile motion, if you carefully see. Here with some velocity it is thrown and at an angle of 30 degrees also clearly given. Now, what happened? What is the distance from the foot of the tower? This is the foot of the tower to the point where the ball hits the ground. So the ball will be hitting the ground in this way. Okay. So this is what imagine distance D. So this is more than the range of a projectile. Yes, sir? So this is the range of a projectile actually. This is the range of a projectile. And this is the more than the range of a projectile. So this is the distance between the foot of the tower to this point they are asking. Whatever it may be, horizontal distance is only the D. Okay. So let me write here. So this D is equal to horizontal distance. Horizontal distance. So whatever it may be, horizontal distance is equal to speed into time. Horizontal distance is equal to horizontal speed. What is that? Horizontal speed into time. Horizontal speed into time. Okay, what is this time? Time taken by this particle from here to here. Right? Time taken by the particle from here to here. Understand? Now here this is your u cos 30 degrees and here there is a u sin 30 degrees. When we are talking about time of flight, we should concentrate on the vertical motion. Okay, so the total vertical path traveled by the body, that's the time of flight. Understand? So here, horizontal speed, so D is equal to horizontal speed is u cos 30 only, u cos theta only, into time of flight is t. Here the important. Generally, if it is a projectile motion, time of flight you can easily find, but it is not the projectile motion. Only the projectile motion is still here. And what is this? Now, if you really focus on this is the concept is similar to there is a tower of height h and from here a body is projected up with some initial velocity u and the body will be reaching the ground back here. In this case, in a time t. Okay, in this case, what is the height of the tower? Did you remember the formula? Is it half gt square minus ut? Yes or no? This is the case in motion in one dimension we had discussed, my dear students. Here, same way you can find the time taken by the particle to reach the ground. Time taken by the particle to reach the ground. Here you can see, in this place u will keep u sin theta. See here, u sin theta. So, from this topic, h is equal to half into gt square minus uy into t. From here, what I can write, h is 61 meter, which is equal to half into 10 into t square minus u sine 30 degrees. Okay, it is u sine theta, right? U sine 30 degree into t. From here, if you solve, you get t is equal to 5 seconds, my dear students. What is that? T is equal to 5 seconds. What is this t? T is the total time taken by the particle to reach the ground. Because t here is time taken by the particle to reach the ground from the vertical projection, from this vertical projection. So this t is equal to 5 seconds. You substitute here, you get your answer. So d is equal to, what is that? U cos 30 degrees into t is 5 seconds. So you get this as 105.6 meters. You can check it if you want. Alright. In this way, the numericals will be asked, my dear children. Right? The numericals will be asked in this. I hope you are ready to solve some more numericals now. Right? Let's move into the another numerical. Right, this numerical is like this. A gun fires a bullet. A gun fires a bullet at a speed of 140 meters per second. If the bullet is to hit a target at the same level as the gun, at the same level as the gun, and at 1 kilometer distance, and at 1 kilometer distance, the angle of projection may be, all right. See, let me write the options available here. 60 degree or 30 degree. Option 2 is 40 degree or 50 degree. Option 3 is 15 degree or 75 degree. Option 4, 20 degree or 70 degree. Okay. Look at the interesting fact behind this question. So look at the interesting fact behind this question. A gun fires a bullet at a speed of 140 meters per second. So given u is equal to 140 meters per second. If bullet hit the target at the same level as the gun and 1 kilometer distance, The angle of the projection may be, see here, the bullet is to hit a target at the same level. Means where the target is kept, there only the bullet is hit. And at 1 kilometer distance, that means maximum horizontal distance it is traveled. Okay. If bullet is to hit the target at the same level as the gun and at 1 kilometer distance. So what I can say here is, this is what happened. This is the target. Target is at 1 kilometer distance. The angle of projection may be, right? This is called the range. Will you agree with this? This is the range. So that range is equal to u square sine 2 theta by g. That's the range formula. So that's the range formula you have. That range is given as 1000 meters. Initial velocity is also given. G is also there. Then you need to find the angle of projection. Simple. But angle of projection will have two angles here, you can see. Angle of projection will be there, two angles for theta and 90 minus theta. Ranges will be seen. Here you see, if it is theta, it's 90 minus theta. If it is theta, it is 90 minus theta. So if it is theta 90 minus theta, theta 90 minus theta. All the angles are satisfying theta and 90 minus theta. Now let's find theta, then 90 minus theta you can check. So initial velocity is there. Let's write range is 1000 meters is equal to u square. It's 140 into 140 into sine 2 theta divided by, I can say it's 9.8, and I forgot to write in the question. They gave, take G value is 9.8 meter per second square. Here, 1 0 and the point cancel here. So this is 9800, which is equal to 14 and 14 is 196 and 2 zeros have been keep. It is sine 2 theta and 2 zeros and 2 zeros gone. 98 ones and 98 2 0. So 1 by 2 is equal to sine 2 theta minus 2 h. Sine 2 theta is 1 by 2 from here. 2 theta value, when this 2 theta value is 30 degrees, then only sine 2 theta is 1 by 2. From here, theta is 15 degrees, my dear students. But there are two options here. The same range is also possible. Imagine if this theta is 75 degrees for 15 degrees projection also. For 15 degrees projection also you get the same range, right? So when theta is 15 and your 90 minus theta value is 90 minus 15, it's 75 degrees. For this 90 minus theta, for this theta, you get the same range. Understand? So that is what the correct option is, 15 and 75. I hope you understand the situation here. Alright? Clear? Are you ready to solve one more question, students? So, see, there are so many homework problems and assignment problems and degree review. So many. Let's have a look at the other question. An object is projected with a velocity of u is 20 meters per second and making an angle of projection 45 degrees, my dear student, with the horizontal. The equation of the trajectory, they have given y is equal to ax minus bx squared. So what is that? So this is the equation of the trajectory. Now, the question is, a and b are constants. Find the ratio of a by b. What's the ratio of a? Alright? What is the ratio of a and b? Now, we know a by b is the range. So range is equal to u square sine 2 theta divided by g. U square is 20 into 20 into sine 2 theta is sine 90 is 1 divided by g. So this is 40. This is the question we had learned already. A by b value they are asked, that's range. So sometime the question may be b by a, which is 1 by 40, and this, if for example, if you forget the value of a by b is equal to range, and you can also do it this way. You have your a value, which is equal to tan theta. You have your b value, which is equal to g by 2u squared cos squared theta minus 2. From here, from there, from 1 is equal to x tan theta minus gx squared divided by 2u squared cos squared theta. From here, right? So you find a by b, you get the answer. That is equal to the range of the projectile. All right. So that is equal to the range of the projectile. Understand? So this is the question. So many times we have done. This is how numericals will be asked. Are you ready? Let's have a look at one more concept. All right. The concept is horizontal projectile motion. Okay. What is the concept here? Horizontal projectile motion. In this horizontal projectile motion, what are we going to learn? Look at here. So simple that there is a tower of height h. There is a tower of height h. From here, we are just throwing the particle horizontally like this. Right? How? This is what? With initial velocity u we have thrown. You know how it will? So it will never move in the same direction because the gravitational force will be acting on it. That means the acceleration due to gravity will be acting on it, and finally it will move in this direction. So this is, imagine at some particular point, at this particular point. Okay, so it is at x comma y coordinate at point P. So this is the x coordinate and this is the y coordinate. And it is y and this is x. And time taken by the particle to move from here to here is t. Right? Time taken. This is, imagine this is the initial point I. Time taken by the particle to move from point I to P is t. Listen. Here, what is this x? X is over t. Initially here, horizontal velocity, initial u x is equal to u. And vertical velocity initially is 0. Understand? After some time there will be the vertical velocity because at this instant, so if this is the velocity v, it will have two components here. So this is vx and this is vy. Right. So throughout the motion, this is constant. Okay. So throughout the projectile motion, horizontal, throughout the horizontal projectile motion, this is constant. What is constant? That horizontal velocity will be constant. Let's see. because there is no force acting on the particle in the horizontal direction. Only force acting on the vertical direction because of the acceleration due to gravity. Okay, remember this. Now, I can say x is the horizontal distance, which is equal to horizontal speed into time. Time t. I already wrote. T is the time taken by the particle to move from here to here. So from here, I can write t is equal to x by u. Just keep this as equation number 1. Now, can we see y is equal to uy into t plus half gt square. This is the vertical distance traveled by the body from here to here. The vertical distance of displacement, it is the vertical displacement. So y is equal to this one. So here uy is 0, 0 into t is 0. So I can say y is equal to half gt square. So this is equation number 2. And this equation number 1 you can substitute. Equation number 1 you can substitute, my dear children. When you substitute equation number 1, you get y is equal to half into t into t square. T square is x square by u square. So this finally I could write. So y is equal to 1 by, see that is g by 2u square into x square. So this is in the form of y is equal to kx square, where this is equal to k. Okay, so y is equal to kx square. So this is also an equation of parabola. What is that? So this is also an equation of parabola. So here horizontal projectile motion path also equal to parabola. Oblique projectile path is equal to parabola. This is also the proof of path of a horizontal projectile is parabola, and we have already done the proof for the path of a oblique projectile is also parabola. All right. Clear? Remember, this derivation is also important. Okay. Now, at this instant, let's find the velocity. At this instant, the velocity of v bar is equal to, carefully see, vxi bar, vxi cap minus vy j cap. And let's focus on vy here. So vy is equal to uy minus, right, or plus gt, because the particle is moving in the vertical direction downwards. That's the reason, plus g. So anyway, so this uy, what is this uy? Uy is initially 0. Yes or no? Uy is initially 0. So I can say this is gt, right? So finally, this you substitute here. So v bar is equal to, okay, v bar is equal to vx. Vx is u. Vx is constant, I told anywhere vx is equal to u. U into I cap minus vy. Vy is gt into j cap. So the magnitude of this velocity at any instant will be square root u square plus the gt whole square. So remember, so this is the instantaneous velocity at any instant. Instantaneous velocity of a horizontal projectile motion at an instant. Okay. Clear? Here also you can find the concept called time of flight. What is this? Time of flight. So let me find the time of flight, my dear students, in this case, time of flight, which is denoted with the symbol capital T. Total T, from here to here, time taken is small t. Imagine particle has traveled from here to here. Total time is time of flight. And when it is traveled the total time from here to here, total vertical distance traveled is h. Yes or no? Once again, when the particle is traveled, the total time taken from here to here, it is traveled the vertical height h. So if I use the formula y is equal to uy into t plus half into gt square. So this y is equal to uy is, this is 0. Okay, this is 0. So half into gt square. So from here, this is h. Okay, so h is equal to half gt square. So from here, t is equal to square root 2h by g. This is the time of light, my dear students. If you really understand the time of light concept, and one more point I just wanted to tell you. One more point. So time of flight is independent of the initial velocity. So let me write here. So this time of flight is independent of initial velocity of the projection, and it is independent of mass of the body. Understand? This is the time of flight. And if you, when you understand the time of flight, and it is so easy. It is so easy to find the range of a projectile, students. Maximum horizontal distance from the foot of the tower to here. Maximum horizontal distance, that's called range. And this range of a projectile, which is horizontal motion, horizontal velocity into time of flight, because range is horizontal distance, which is equal to horizontal velocity into time. So range is equal to horizontal velocity is u only, and time of flight is root 2h by g. So range is done. Instantaneous velocity concept is done. Time of flight topic is also finished. All right. Now, horizontal projectile motion, we have basics are done, and we proved that the part of this is also parabola. Part of the horizontal projectile motion is also parabola. Now, study of projectile motion. The study of projectile motion is called ballistics. What is that? Ballistics. The study of projectile motion is called ballistics. Now, different cases in horizontal projectile motion will be discussed in the next class, my dear students. All the very best for your assignment. Thank you so much.